All right, welcome. Thanks for being here. My name is Jeffrey Palermo, and we're going to be talking about setting up brand new ASP.NET MVC projects from scratch and everything around it. There's so many. Somebody's got their volume on. There's so many avenues and tutorials and quick starts about the MVC5 feature set and how to work within the features of the framework. But what's completely missing from all the content is you're building a software application. MVC is just the UI. What about all this other stuff we have to do properly, or else we're just going to end up wading through mud a few months down the road once the greenfield aura wears off. Okay, so that's what we're going to do. Welcome to Houston TechFest. Thank you very much for being here. Cell phones, yada yada, and thank you so much to our diamond sponsors. Very, very exciting. Here's a link you can use to leave feedback, and if anyone needs to write that down. Also, the hashtag HTechFest on Twitter or Facebook, and you can get my Twitter account. It's at Jeffrey Palermo. So that's available too. I don't see anyone taking a picture of the QR code up here. All right, sponsor slide. Let's get going. So again, this is iteration 0 for ASP.NET MVC5. We're starting a new piece of software. We're not. It's not a. It could be an upgrade if it's a rewrite. You're laying down a new source code repository. We're starting a new piece of software. It's going to be an MVC5 application, and this is what is the first week. All right. Iteration 0 is not about features. It's not about anything on the backlog of what the software is supposed to do. It's all about setting us up for success, setting us up for a frictionless development environment, and enabling some patterns for the team to work together. Okay? And admittedly, all of these things are going to be really, really useful in a team environment. If you're working completely by yourself, I think you'll get a lot of benefit as well. But if you're in a team environment, not doing these things is just setting yourselves up for difficulty. So it's very important. All right, agenda. We talked about what this talk is and what this talk is not, but it's not a beginner talk. I'm going to expect that you have already done some MVC5 or at least MVC4 because this is close enough, because I won't be getting into some of the basics of how it's put together. So I do expect that you've done that before. I expect that you're well versed in C#, Visual Studio, how the compilation model works, how the runtime works, things like that. And I'm going to get into some higher order software engineering concepts that build on top just the basics of how the software works. So I would peg this level at a 300 level of the 1 through 400 scale. Okay. Well, I'll talk a little bit about myself briefly, just so you know how to contact me later. We're going to talk about what the web stack looks like, why configuration management matters. We'll get started with the new MVC5 project. We'll look at the source control element of how to lay down a source control repository for that new MVC application. We'll look at how to structure the Visual Studio solution, and then we'll get into how to do an automated build, some continuous integration, and automated testing around this MVC5 application. Okay. All this is geared to set us up for success down the road and not get into a point in time where we start slowing down because we haven't put the right foundation in place. You can find me, it's actually very, very small text on the bottom. If you Google for Safari Online MVC5 Palermo, you'll get to my recent MVC5 training that's on Safari Online. It's somewhere between, I think it's around 7 hours of online video training on MVC5. I did have one on MVC4, and so it's been upgraded as of May. So that's on the Safari Online and Sam's publishing site. Pretty much every big company subscribes to Safari Online, so if you don't know that you have it already, you might, and otherwise it's pretty cheap. So that's some in-depth MVC5 training on all the feature set, including Web API and whatnot. I'm from Austin. I drove in, although I was born in the original Herman Hospital right here in Houston. And so I've been in Austin for 15 years. I've spoken at various conferences. I ran the .NET user group in Austin for a long time, and I've spoken at Microsoft Tech Ed and some different things. And also cover the book. I've got ASP.NET MVC5 in action. There's 3 editions of that book that are out on the market. You can see at Barnes & Noble or whatnot. And, of course, bragging about the kids and all that jazz. All right. And of course, I like off-roading with the Jeep. You can't see it, but my license plate is HTML5. So I kind of like that.
Nice.
So it's a jacked up Jeep. It's out there in the parking lot. The bumper is not that clean anymore. We are hiring. And on to the next thing. So we got a big web stack these days, and the features keep piling on. The technologies keep piling on, and it's not going to stop. Why? Because it's never stopped before. And people say, oh, technology is moving forward faster and faster every day. I don't think that's right. I just think that the more you pay attention to it, the more you notice that the technology is moving on. But there's 2 sides of it. There's the side that is moving on, and then there's the side that's the same as it was 20 years ago. All right? And UI technologies and UI frameworks, yeah, every 5 years, the vendors that are pumping it, Microsoft, Telerik for the SPA stuff, I mean, everything, every 5 years, they're going to say, hey, we got something new. Yeah, 5 years ago, I know I sold you on this, and I know you bought in, and I know you're doing it, but this is something new. We like it even better. Oh, it's not that the old stuff is bad, but it's done. You should definitely move to this new stuff. And then it happens, and data access frameworks every 3 years, and at one time it was every 18 months. This is how you should be talking to a database, a data store, SQL server, document database, whatever. We get new guidance from Microsoft and other vendors who are selling stuff about, hey, do it a different way, do it a different way. And what about integration? Web services with just JSON going over HTTP is the current way to do it, and there have been improvements, but what about when everyone was shouting, send XML, and then before that, everyone was shouting, send SOAP, and then it was binary protocols before that with Corba and remoting, and so that stuff is never going to stop evolving. However, if we don't lay out the foundation for our application at the beginning, understanding where those pieces fit, then we end up in a place that you're all very familiar with, because I'm sure every single one of you hasn't been involved with a rewrite application. All right? You're going to rewrite some software. Did the people before not know what they were doing? Were they screw-ups? Why do we have to rewrite it? Why do we have to throw it away and start over again? Why weren't we able to just port it forward and maybe upgrade maybe one layer or upgrade one aspect of it, but carry the application forward? Why does some software get to a point where you literally throw in the towel and say, sorry, it is so bad, we can no longer modify this. We would be better off to throw it away and start over again. And yeah, we'll try to salvage some of the parts, but don't get your hopes up. Why is that? Any comments?
Maybe the guys writing it before really didn't know what they were doing.
Maybe so.
Maybe we don't know the context of the decision they made.
The context of the decision, yep. I would posit that that because it's been that way for so long, our industry as a whole doesn't have widespread patterns or conventions that actually assure us that the software we're writing today won't have the same fate 5 years from now, and definitely 10 years from now. How do we know that the software we're writing now isn't going to be talked about in a historical context about one of those pieces of software that we can no longer modify and we have to throw it away and start over again? How do we know? We're going to explore that. Okay. Now, why iteration zero matters? Who subscribes to Scrum, whether it loosely or tightly or whatnot? You talk about it at work. Okay. All right. Most of the audience. So you might have used a burn down chart where you start off with some amount of work and you're going to burn it down, right? And so the bottom axis is weeks, and right around 14 weeks we're planning for a QA drop because we're getting started, right? We're getting started, and obviously, if we subscribe to Scrum or Agile, we want every iteration to be working software. But of course, the first and second week, we're not going to produce working software because there's really nothing to really show. And so we tell ourselves the story. And so we say, you know what? Iteration 14 or week number 14, okay, yeah, let's get to that part where we're producing really working software. Up until then, we're just given a status report. And it's just, oh, yeah, okay, we're on track. Because you really don't have anything real. And then the QA drop hits, that's when there's reality, because that's when we're forced to bring it all together, which is commonly called as integration, bring it all together, make it all work together so that another group, whether it be one person or whether it be a formal QA department, can use it and see it for real, and all the pieces have to be connected. That's when we get the real feedback. And so many times, we give ourselves a really good sense of how good we're doing because we're laying down a lot of code. And then QA drop hits and they expect it all to work for real, and then there's some bug reports. And then, oh, it can't. And so then we're derailed and it completely goes off the rails. And then we were given the, oh, it's on track, we're on schedule, on track, on schedule. And then we're not on schedule. We're going to talk about preventing that. Because in our industry, that's really not acceptable, and we can prevent it. And iteration zero, and then carrying that foundation that was laid in that period of time at the very beginning is instrumental in this, in keeping a steady flow where 3 months down the road, maybe in 6 months down the road, you don't get to a point where it started out greenfield code and you're so happy to be working on something brand new instead of slogging through somebody else's code from the past. But in 6 months, you realize that now you're slogging through your own code from the past. All right? That's why iteration zero is so important. So some of the concepts in iteration zero are about software configuration management. There's a whole book on it. It's got a subway train on the front. I recommend that you read that. Configuration management best practices. It separates configuration management into 6 pillars: source code, build engineering, the environment configuration, change control, release engineering, and deployment. We're not going to get into the last 3 here. That funnels into the integration with production operations and DevOps. And if you've heard of the term continuous delivery, some of those concepts, we're talking about, okay, we're just starting. What do we need to do right now at the very beginning before we've actually put any features into the software to set us up for success going forward? And then later on, of course, you want to bring in these concepts. I recommend reading that book. Also, I recommend reading Continuous Integration book. In 2005, this book came out, 9 years ago. Okay, some people still aren't using continuous integration. 9 years ago, there was a very easy to read book written about how to do it and why it's important, and products. There's plenty of products these days that help. All right. Everyone see this to read it. Take a minute to read this, please. Has anyone ever heard of Martin Fowler before? All right. I think he sort of knows what he's talking about. At least the publishers have thought that because he's written so many books. I've read so many of his books. He's a brilliant man. I would paraphrase all this into one word. This is a solved problem. It's not widely used in the industry, but it's a solved problem. It's just up to us to learn from the common body of knowledge in our industry and put it to work. And so that's what we're going to be going over today. All right, the goal of iteration zero is expressly not to produce any sort of features whatsoever, but to lay down the foundation for being able to work in a new piece of software. At the end of it, this is the workflow that we're going to enable. You've got some size team. Maybe it's only 2 people. Maybe it's 15 people. But you have a team, and all of them are going to be working on the same source code repository so that when they make a change and push it up, there is an automated build server that grabs those changes, runs through a rigorous build process that validates lots of things, tests, configuration, the compiling is definitely a part of that, and gives feedback if something that used to work is now broken, to enable the developer to say, oh, well, let me revert that. Hold on, I wasn't done yet. The rest of the team, yeah, you keep on working. I made a mistake, and try again. And then if everything works, that means that, okay, I didn't break anything that was there, but I've added a new behavior to the software, and I've got a deployable and releasable package as working software. Common times, it's a zip file. For a lot of online applications that are going to run on IIS, zip file works just fine. Or I know Octopus Deploy is integrating really well with software packaged up as NuGet packages, which essentially is a zip file. So zip is essentially the pretty well accepted form of a release package. And if anything's wrong along the way, we want to stop. We want instant feedback. We want to be able to undo the misstep that we just took and then carry on before. All right. This process prevents and eliminates situations where you got a team, one person checks something in, and maybe they didn't know that they broke something in some other piece of software. Another developer finds it. Hey, you broke me. And, oh, okay. Hold on. Let me work, and I'll get that fixed. And they work the rest of the day trying to figure out what they did. And sometimes they might bang their head against the wall. But in the meantime, you got all this rest of the team that they're told, hey, don't get latest. Don't get latest. It's going to screw you up. And they're like, okay, I won't get latest. All right, well, I'm done with my stuff. I'm ready to look at the time. So is anyone experienced something like that? Team, right? So we want to prevent that. There's really no reason we have to experience that, because the patterns are out there. It's a pretty easy formula, because we're all going to make mistakes, but we employ computers to compensate for the mistakes that we make. It's not like we're not going to break the build. It's not like we're not going to screw things up and forget to check in a file or some weird configuration setting, or even completely blow it and hose the source code repository. We're going to do that. It's going to happen. So we have to have a process that protects the team's productivity so that when reality happens, because it's going to, it doesn't screw us up. All right? So that's what we're going to go into. There's three main areas to set up right away in continuous integration. We're going to dive into code of each one of these. All right? Code, PowerShell scripts, organization, the whole bit. We want to set up the source control structure. That is, what are the important top-level folders to use? What levels do you put certain files in? It's not just a network share. You don't just, hey, we got a source code repository. It's a network share. Let's just start dumping stuff in. There are established patterns in the industry and conventions we can follow that are anchored in publications and whatnot, where for the folks who have heard of those conventions or seen this talk, because it's just an extension of other things that are in books and magazines elsewhere, they can come in and say, oh yeah, okay, I know how this is structured. Yep, it uses a pretty much standard organizational structure. Next, we're going to gather the dependencies together. If we're laying down the source code repository, then I'm going to assume we're at the point where we've decided what the overall software architecture is going to be. You've decided what the basic structure is, and you can set up the bones of the software. So gathering the dependencies and figuring out where they should go. And then step 2 is all about pulling that together, get the compilation going, which is easy because Visual Studio, and then the basic testing, some of the automated testing we do with in-unit, and then packaging it up in a release package. We're not going to go into depth in step 3, which is deploy and testing, as it bridges over to production operations. But if you haven't heard of continuous delivery or DevOps practices, I encourage you to do further research. Let's get into the version control system. It's also called source code control, SCC, or VTS. There's two, and largely non-locking. A lot of the non-locking crowd will say non-locking has one. It's also called distributed version control. Locking is centralized, where it says, okay, only one person can modify one file at the same time. 10, 15 years ago, Visual SourceSafe pretty much mandated that, hey, we're going to lock it at the server, and you can look at it, but you can't change it at all because somebody else on the team has it locked. And TFS also has a mode where you can have centralized locking of files. The other camp is, no, we're going to have so many branches. Anybody can modify any file at any time, and we'll just worry about it when we go to push it up to the central server, which one wins and how to merge. All right, those are the two camps. Largely, the non-locking and distributed has won and gotten more traction in the industry, and we're going to be using Git and that style of version control just for the examples here. And I think it works a lot better with team development and the modern software engineering practices that Agile and extreme programming have introduced to the industry. All right.
Particularly well with remote developers.
Good point. Yeah, remote developers. So for Git, there are two really good tools to use on Windows. One is Tortoise Git, which integrates with Windows Explorer, and the other is actually a new tool from Atlassian called SourceTree, and works with Git or Mercurial. I'm not sure if they've added support for anything else. But what's also something new that came around in 2010 was a convention for a branching model called GitFlow. All right, who's ever heard of feature branches? All right, feature branches is a really good pattern to use where you have your master branch and you create a branch for a feature. One or more people work on it, and when you're done, okay, now you merge it back into your master branch. That works for sophisticated teams and sophisticated developers who have already got this well established in the culture of the team, and they're saying, you know what? We know that features are so good. When we merge a feature into master, it's ready for production. We've gotten sophisticated testing. We've got our continuous integration down pat. We've got everything in there where once we merge a feature branch back into master, we just don't have problems going to production. Okay, works great there. What the common discourse in the industry since 2010 is, for the majority of the rest of the industry that does need to go through whether it be formal or informal, just a focused check of, okay, we did some stuff, we think we're good, but let's go through a process. Some people call it QA or quality control. Let's go through a process and just hammer on it before we actually push the button to go to production. All right? Most people do that, okay, because most people aren't to the sophistication level with their continuous integration where they have confidence that, hey, if the build works, it's ready for production. Most people aren't there yet. There are some that are there, and for them, feature branching is all that's necessary. But for most people who need that extra step of, well, let's have a formal quality control process and all look each other in the eyes that we're ready for production. All right. For that, GitFlow works really well because it has one more step. And I'm not going to go in detail through here, but if this is the master code line, and you have all the versions that are ready for production on the top, this is a line that is called develop. This is what everyone develops on, and you can see the green on the bottom left. That is for feature branches. Feature branches come off of develop and then merge back into develop. When enough features have been put in there to warrant a production release, a release branch is created off of develop. And then you maybe increment major or minor version numbers, do some other stuff, documentation, and then once that's ready, instead of a code freeze, you let develop continue on because you've got a release branch that is frozen from a feature perspective. Then merge from release back into master, and then boom, then you go to production. Okay, that's the whole gist. And the red one over there, that's for a hotfix from production. Okay, so GitFlow, there's plenty of documentation and people who have written about it since 2010. So we're almost 4 years of GitFlow having gotten traction, and it's already made its way into a couple of products. Atlassian SourceTree is one of them, and I'll show you that in a little bit, where it has it built in workflow around Git. source control tools can be pretty complicated. Git is command line at its core, and all the rest of the tools operate on top of that. Source tree provides a pretty good GUI that abstracts away all the command lines, because most people in our industry are not going to really get good at the command lines. They need just some simple buttons and constrain down the feature set. But it's important to get the source control model well established when you're setting up a brand new MVC project. Also, and after this we're going to dive into Visual Studio and look at the code for this. Also, besides setting up the source control structure and the branching model with your team, you need to set up the Visual Studio solution structure. Now, when you go into Visual Studio and it's a blank slate, Microsoft has this great project system where you say File, new project, and Visual Studio asks you, what type of software are you building? No, it doesn't ask you that. It asks you, what would you like the user interface to be? That's the question that it asks. Completely backwards, right? Right? Because we don't need to decide on, well, we've already decided. We've got the architecture laid out. We've probably got some whiteboard drawings. We might actually have it in a PDF or Visio. We've already decided what we're building. Otherwise, what are we doing laying out some structure in Visual Studio anyway? So we already know the basic structure of the application that we're building. We know if it's going to connect to some downstream systems. We've worked out some sort of data flow. We've decided what type of database it's going to have. We've decided if it's going to have some element of an offline batch job, or maybe we have some real-time streaming if we need to have messages or data packets constantly coming in. We've already decided what type of software we're building. So we go into Visual Studio and we say, okay, let's get started. And Visual Studio says, what UI would you like? And so we have to start with that because it forces us to. So we say, okay, I'm going to have a new MVC5 application. And we hit go, and of course it says, would you like to create tests? Would you like to include web API? I'm not going through the new project setup because all of you have already done that yourselves, right? Give me a hand if you have. Okay, great. Got to see some nods. Perfect. So it asks us the wrong question. We have to compensate by just doing it manually because there's no wizard in Visual Studio that helps us set up the software that we're building. It only helps us set up the user interface that we're building. In fact, if you rewind, let's go back. Who's ever done web forms programming? All right, great. Just for context, I started programming web applications for IIS in 1997. Now, most people think that Active Server Pages created a little code nugget, right? No, it didn't. It inherited it. IIS 2.0 had dynamic web applications with a file extension called .idc and HTML templates called .htx. It stood for Internet Database Connector, and then hypertext template. And the Internet IDC file could specify a query to run against an ODBC data source registered as a DSN, and you had a record count, you had a loop, you had a conditional operator, and then you had a print to print it interwoven with HTML. And of course, tons of nested tables were the rage at that day. So IIS 2 had all that stuff, and then Active Server Pages, but Web Forms was supposed to say, Active Server Pages, man, everybody's just putting all of their code in the ASP files, and it's just all there. It's just mud, right? There's no structure. Can I have an amen? And then Web Forms came along, gave us a whole lot of structure, right? And so you would create your new Web Forms project, and we would open up a page, and Microsoft in the pattern said, I got you. Double click on this button, and you can put some code right here. And if you need to have some code to load this page, we've got a method for you. It's called page load, right? It's great. They gave us all of the patterns we needed for our whole software right there in the UI. We deride and we make fun of Delphi and Visual Basic desktop applications that maybe we inherited. We call them legacy applications and joke about it because we can't bring them forward Because once you take away the desktop screens, you don't have any code left, right? And so we're building it for the web. Let's just upgrade. Oh, you can't do that. Well, I mean, it was built for desktop. It's all intertwined. It's not that it was just built for desktop. It was built poorly. It didn't have any structure. They didn't do this exercise of thinking about the structure of the software that they're going to be building. Now, so web forms, we did that, and so we rewrote these desktop applications with web forms, and it was awesome because it was on the web, and we could get to it from anywhere, and we didn't have to deploy to hundreds of desktops. You could just go to a URL, and the deployment problems were solved. But we were building them the exact same way. Now, Microsoft made it easy for us, and it's easy for us to say, hey, he told me to. I put it in page load. I put it in the button click handler. But all of that is still user interface. You take away the user interface technology, right? Who here is upgrading a web application to MVC? Anybody? Or are you just throwing it away? Most of the time, you got to throw it away. Why? You take away web forms because you're swapping out the UI technology. You take away the pages with the code behind. You don't have any code left. We have a decade of repeating what happened in the 90s. The same thing happened. But MVC solves all that because we go and file new MVC project, and what does it give us? It gives us a lot better patterns. Why? Because it gives us folders in the UI project for models. And it separates the concerns, and it gives us controllers with controller actions so that we can keep our code away from the HTML and couple it just to a different UI framework, right? So what's going to happen all over again is there's some rumblings of SPA applications. And it's early. The frameworks aren't there yet. For the people who are doing it, it's hard. It's kind of like bleeding edge where they're bleeding a little bit because the framework is just not easy. It's hard. And everyone's having to figure it out for themselves. But if you look at the time when some good frameworks come out where the majority of programmers can actually do richer applications in a browser that are touch friendly, that are tablet friendly by default, but also work on the desktop, that next wave of user interface technologies, we're going to come back and say, man, this group that built this MVC application, I'm trying to upgrade this to these REST web services so that my JavaScript can call in and get some data from the server. But by the time I take away all the views and controllers, there's no code left. So it's just like a broken record, right? And it's not the technology's fault. The problem is that there's humans involved, and we don't change. But we can change, and this is what this talk is about, and enough of the comedy. This is a structure at its core that can actually prevent the broken record from spinning all over again. And the core concepts, and there's a pattern called onion architecture that came about in 2008, and I originally started writing about it and coined the term, but there were a whole lot of people in the mid-2000s that were talking about dependency injection and pushing complexity to the extremities, away from the core of an application. And Robert Martin has talked about he has a book called Clean Coder, and he talks about clean architecture. And Alistair Coburn has talked about some concepts called hexagonal architecture. And so the concepts here are not new, but it seems like the term onion architecture has gotten a lot of traction and is stuck. If you Google for it, you'll see like people that there's people giving presentations with it, user groups in Chicago and whatnot. So it is getting traction as a pattern to describe how to structure a Visual Studio solution so that we don't put all the code in the UI. We don't put all the code intermixed with our data access technology, our integration technology, much less the user interface. And I used Visual Studio to generate this, but what you'll notice is that it's not the typical block UI, talks to business layer, talks to data access, talks to database. Because that's just, in math class, you've heard of the transitive theory, right? If A depends on B and B depends on C, then A depends on C, right? So it's still, and it's why even separate it. So this, we have our core, which is, and I'll show you in a minute, it's completely different, where the infrastructures, our data access, and our user interface are actually built on the foundation of the core. And then we have tests that are a higher level that the application is actually a foundation for. So let me go into Visual Studio and walk you through this. All right, so our MVC5 project, right? Let's look at the references. Visual Studio gives us tons of references. The ones that I added were that one, core. That's it, core. That's the one that I added. All right? That's all. That's all it needs. We don't. It's a user interface project. The only code that belongs in the project that is our MVC5 project is just user interface stuff. Not, hey, what does this application do? How does it function? No. Because it's gonna do what it does regardless of what user interface technology we happen to choose. Just the code that talks to the framework elements of MVC5. Right? So project references matter. Namespaces within the project don't matter, and then they don't have any teeth, right? You got to figure out some conventions for the namespaces, but they really don't have any teeth. The folders within a project that sort of correlate to the namespaces, it doesn't help you, all right? It's important just from being able to organize things, but it's sort of like, do you use tabs versus spaces, or do you put the curly brace on one line versus the other? Okay, yeah, pick one, but it's not going to change the structure of your application. Project references are the structure of your application. I would go far as to say this. If someone adds a project reference without talking to the team, that is malpractice. Project references are the Visual Studio representation of the structure of the software. We start with a picture of what the shape of the software is going to be. Oh, let's draw the architecture on a whiteboard or Visio or whatnot. Okay, this is going to be it. And at ClearMeasure, we have some clients that are venture capital funds that they're going to acquire a company that has some strategic software, and they have us go and evaluate the software and see if it does what the owners are saying that it does. And we go in and they give us this, hey, here's a Visio of the architecture of the diagram. And we look at the code and we look at the picture. And we're like, did we get the wrong picture? Yeah. I mean, we're trying to find the structure that was intended to be the architecture, but it's not there. Project references are the implementation of the structure that you decided on. Okay? All right, so let's look at core. Core?
And it's worth going back through the references during code reviews and making sure you didn't add something unintentionally.
Good point. Good point. All right, references. When you create a class library in Visual Studio, it gives you, Microsoft gives you like 10 or 15 references by default, including system.data. It gives you system.data for a class library. All right? Now, backwards compatibility, there's probably some Microsoft that want to change that, but then, okay, well, backwards compatibility. So this project right here, core, this project is our precious diamond. This is the most important project in our application. Now, down the road, do you want to at some point maybe separate out core into maybe some different class libraries? Maybe, but most of the time, no, unless you're a product vendor and are going to be strong naming your assemblies and holding tight an encryption key and then selling your DLLs like Telerik or Component One or those other component vendors. That's a whole different story. If you're building the software to run on servers that you control and you're not giving anybody access to the assemblies, your Visual Studio solutions should have a handful of projects, no more. Not 12 projects, not 40 projects. There's no reason for that for internal software. External software with strong naming and all that, different constraints. But if you're building software for yourself, big old Visual Studio solutions just hinder the productivity. So we've pared down the references to just really core .NET framework. These dependencies don't have any tentacles. System.core, system.component model, .data annotations. Those are just little attributes that, you know, some other things. But there's those dependencies don't have any tentacles. It's just sort of core .NET stuff. It's just like being coupled to C#. You're coupled to this stuff. All right. You want to shove all of your code in the core project, and you want to figure out novel ways of saying, well, you know, I was really doing some data access. Okay. Let's figure out the 80% of that code that can be done, teased apart from the data access framework you're using, and pull that into core, and maybe the 20% of that really is inextricably linked with the data access framework APIs. Okay, maybe that has to stay. But I bet you we can get 80% out of there and into core, because the data access framework is going to change later on, and you're going to want to swap it out. And if you don't do this, you won't be able to swap it out. MVC, its days are numbered. All right? We can, the writing's on the wall. We got these SPA applications coming out. We got Web API that has no commonality with the MVC stack. System.web is going away. If we put all of our code, or even too much of our code, intertwined in our controllers, that code's throwaway. When it comes time to say, hey, let's upgrade, let's move from MVC 5 to MVC 6, which is not going to be based on the same stuff, how much code are we going to have to throw away? All right? All this is iteration 0, setting ourselves up for a chance of success or guaranteed failure. And I define failure as having to ask your bosses to spend all of your money all over again, because we have to. Now, of course, it does happen 5 or 10 years down the road. It's pretty easy to move departments and move employers, and so we don't get found out typically. But the industry, you know, it's kind of a problem. Infrastructure. Infrastructure has our data access framework here. We have structure map. In Hibernate, our IOC container structure map. We got sort of some infrastructure components here. We got the references to them, and and it references core. All right, it references core, doesn't reference it, because if core referenced infrastructure and then infrastructure referenced in Hibernate, what's the point, right? So we've inverted those dependencies. Okay, and then we have some integration tests and some unit tests. So that's the structure of the Visual Studio solution. I'm also going to show you structure of our repository. We have build script with Saki, which I'll show you a little bit later. We have our automated build. I can run here off to the side. We have our source folder. We're inside source, SRC. SRC is just super common. Inside SRC, we have our Visual Studio solution, iteration 0. Can y'all see that okay? And then we have a folder for every one of our projects, core, infrastructure, UI, whatnot. And then we have a config file. In Hibernate, it needs a config file. The config file is at the solution level because it applies to the whole solution. So we don't tuck it into one of the projects, we pull it up to the solution level. And then we have common assembly info, which I'll talk about a little bit later. So I've just run the automated build, and it succeeded. And we'll talk about that in just a second. This is the source control structure. Put your solution one level down in the SRC folder, and the top level is code that configuration management code that operates on your source code, your build scripts, your helper bat files, any tools or dependencies like 7-zip for creating a build package, or AliSQL for automated database migrations. By the way, AliSQL is the trimmed down fork of what used to be called the Tarantino database deployer, if anyone's heard of that. And so, upgrade. And then all of this code can be found on GitHub, and it includes the PowerPoint here. I'm going to show you. So, github.com/clearmeasure/iteration0. If you want to write that down or Google for it. All this code, including the PowerPoint, is there. Let me go back to the PowerPoint and we'll continue. Building the software. And we've got this Visual Studio solution laid out. We've got our source control laid out. If we're really sophisticated, we pick feature branches. If we have some folks that know maybe the basics, but we just recognize that, okay, they're just getting into this thing, we choose Git flow, and we have some specific quality assurance standards before going to production. We've got that all laid out. Next, we need to hook up a continuous integration server that's going to do a build process as soon as anybody makes any change to any file in the source code repository. And all of our stuff, not just code, all of our stuff is in the source code repository. For team development, turn off NuGet package restore. Okay? For team development, turn off NuGet package restore. Microsoft's done some surveys. Most people using Visual Studio Professional are doing pieces of software by themselves, and for those people, NuGet package restore can be convenient, but they're not using any of these practices at all. They're just trying to piece stuff together to get stuff working. If you're in a team environment, turn it off, because it's going to, behind the scenes, say, oh, because I decided, let me get this new version of the dependency. And then you pull something in, the new guys, they've obsoleted some API, and now it's broken, and of course you don't have an automated build, so you push it to source control, and then it's breaking everything. Dependencies, so I harped on project references. Project references are dependencies. NuGet packages are dependencies. Dependencies are the structure of your software system. And yeah, NuGet is really easy, but upgrading one of those is a big deal. We're lulled into a sense of complacency, but okay, Log4Net, we can upgrade that, nothing bad happens, until you're in a hurry, and until you don't have time for something to go wrong, and then it goes wrong. So iteration 0 is about setting up things so that you can move fast. You don't want any. You want to squeeze out the possibility of friction. NuGet package restore is one of those pieces of friction. All right, private build is used by each developer on their local box to test changes before they commit to version control. We're talking about team process now that you establish during iteration 0 with the team around the code. The integration build is the build that happens on the build server. I prefer JetBrains TeamCity as build server software. It's free for a team, and it's pretty darn cheap for bigger organizations. But integration build runs on the build server. It's the same set of steps, except the integration build on the build server should also do the packaging step where it creates the release package zip file. There's no point in doing that on a local workstation. But all the same steps, you want to do it. So environment configuration is part of the build. Examples of that are database connection strength, config settings, environment variables, operating system settings, web server settings. Anything goes in your build script so that it's in your source control. Installing Visual Studio and some version of SQL Server for a lot of applications should be the only software that you have to install and configure on a developer's workstation. Everything else should come from source control. Okay? Furthermore, we found over time that working on lots of pieces of software, and I know that a lot of places work on one piece of software for years at a time. I'm in a different place. ClearMeasure is a software engineering firm. We do lots of pieces of software, and so we've seen the things that are difficult when you switch from code base to code base. And some of those are, okay, you're using SQL Server. Are you using a named instance, or are you using the default? What version of SQL Server are you using? And so you want to pick and have a convention in your organization so that you can put those types of configuration settings in your build script in source control and just say, okay, if you have Visual Studio and a SQL Server with this named instance on your box, that's all you have to set up. You don't have to install in-unit. You don't have to install some sort of thing so it goes in the GAC. You don't have to. It's not this document of, okay, everybody remember to set an environment variable named A to some value. That can be created in the build script, right? There's all kinds of computer configuration that's necessary, but the build script can do that stuff. You don't need to put it in a big Word document. That is the new developer workstation document, right? So you put that in the build script. Just script it out. Okay, we're going to go through the build script we have here. And it is a PowerShell file that uses a build script framework called Sake, spelled P-S-A-K-E. And opening up in PowerShell ISE. And we're going to go through the various build script targets. They're called tasks, but a lot of people call it targets because from make and ant and nant, target and task are sort of the same thing if you hear it thrown around. So, by the way, when you go to GitHub and pull down this code, part of the goal of this is to allow you to completely rip it off and make it your own and use it as either a starting point or a place to pull ideas from. So feel free to completely rip off all this code, the build script, or any file contained therein. And if you let me know that you did it, I will actually feel flattered because it'll have helped somebody. So this build script template actually has roots going all the way back to 2005 and has been honed and tweaked over time. And the lesson is all of the things that change from pieces of software, pull them up into properties and put them at the top. We take this script on a new piece of software, we take this script and we change the properties at the top, and all the rest of the stuff is just, okay, because it's standard stuff. Let me talk about it. Okay, at the beginning of the build, well, we need to sort of delete the old files that were built previously. We need to poke the new connection string into whatever configuration file the connection string was there. In our case, it was in Hibernate. We need to ask msbuild.exe to do a clean operation to get rid of the old DLLs, and then do a build operation on the solution so that we can do the compilation step. Visual Studio calls it build, but it's not build. It's just the compile step. This script is, when you say build the software, it's more than just compiling. Okay. Then once we've compiled, we want to test. Here we're using InUnit, the command line runner of InUnit, to run our integration tests and our unit tests. Then we're going to rebuild the database. Again, this is another critical thing that if you put it in iteration 0, it sets you up for success. Every developer should have their own local copy of whatever SQL Server schema you happen to be using. Shared SQL servers on a development server are an abomination. They don't work. Now, okay, sure, anything will work if all of you are threads and your voice and your hand raised is your locking and blocking mechanism with the team. Because you have a singleton, which is your SQL server, and oh, wait a minute, I need to add a certain field, or I need to add a column to a table. Well, but that's going to break my queries. Okay, how are we going to coordinate so that and it's just setting ourselves up for friction. Iteration 0 is about squeezing out all of the friction from the way the software is set up and how we work together. So, database on every developer's workstation, right? And it's a throwaway schema. I mean, we're going to script it out. We're going to create it, throw it away, create it, throw it away. But it's going to prove that we actually have the schema scripted in source control. We're not going to get it to production and then having to, wait a minute, oh, don't forget to add that field. It's going to be bad if you forget to add the right fields. We're doing a production launch. Or pull out the document that has the fields that you need to remember to add. So putting a database on every developer's workstation is the foundation of this rebuild database step. We have a directory in source, infrastructure, database that's used by the tool AliasQL, which is an open source tool. All it does is look at the directory that you tell it to and run the SQL files in order, each one in a transaction, and then logs to a specially named table what scripts it already ran. Okay. The database migration tools that are built in Visual Studio and other products, they're good, but they figure out what script to run just in time. This mechanism here has the human deciding what scripts to run and actually creating an SQL file ahead of time. So if I were to take this and open Visual Studio so we can see. All right. Do the alter statement. Where is it? Right here. Alter table visitor, add first name column. I posit a human should decide that we need to add that versus letting a tool decide if the tables are out of sync. it's tended to work pretty well. All right, then we have a load data step, which actually runs a specially named integration test that pumps in just enough data into the database so that after you run your build script, you can go into Visual Studio and you can hit Control F5. There's enough data in your fresh database to actually run your application. Because every application needs at least some data, whether it be populating a drop-down list or some token records or whatnot. Very few applications can run with an empty database. Oliver?
Question regarding migration. So it just determines what state that the database is allocated at the table. So it just basically assumes that, no junior developer or something is going to go this organization studio and change the structure.
Well, they might, but it's only on their box. In order to integrate, there's a process. If I added a new first name column on my box, okay, I can do that. But unless I script out a proper alter table SQL file and make sure that it works with the build script and then push it to source control, it's not real. And then if the build is running all those SQL scripts, building up the schema on the build server, and then it's going to run tests that execute queries against it, and if it fails, guess what? That's the feedback. So you can say, wait, hey, junior developer, you broke the build. Let's immediately roll back that commit in source control, try again, the rest of the team can proceed. So yes, people are going to screw it up, but our process keeps it all safe. Because if there is a misstep, we have the ability to quickly undo that step. We don't have to accept the misstep and then add new work to correct the misstep. We just say, hey, you screwed up. Try again. Or let me coach you. If it is a junior developer, you get some mentorship in there. So this works really well. Next, there's some other things in here. One interesting one is the common assembly info to generate a proper assembly info file. A lot of us don't think about that, but if I go to UI and properties and common assembly info, and I open it up, this is a linked file. It's the same file as every other file, every other project has. I'll show you where it is. And at the solution level, right here, it is use the feature existing item and then add as link. Okay, and you can add linked files so that it's the same one. And that way, the build script can push in copyright 2014, your company name, whatnot, those types of things. And so every single DLL in your solution gets tagged with the same stuff. All right, let's go back. Yes, sir.
So, solution, and most of those projects are just basically related to the core, so they're not going to be deployed by something else. They don't need to have different versions. They don't. The way where I try to convey the fact that they don't have to be their own standalone entities. I mean, you say that looking at the need to create additional projects in addition to the core. The witness does this to have a little unit, or what else?
Yeah, I think you're right. If we were to have to add a offline batch job or a Windows service to this application, we would have to add a new project to serve as the EXE or to serve as the Windows service, and it'd be a pretty thin shell, but it would just link in that technology, but then it would reference core and kick off some process. But you're right, we do have to add projects when we have a different type of deployable unit. But those projects can be pretty thin and just serve that purpose.
Right, so I mean, if you have creating new projects in addition to core, just for the sake of organization, doesn't really help.
I think you're right. We tend to have very few we tend to have just these projects in a solution, and then add another one for, like you said, a deployable unit, where there's no way to do what we want to do without adding a new project of a certain type. that we tend to favor as small a Visual Studio solution as possible, while keeping the framework technologies away from our valuable code. The valuable code goes in core, and then the UI, okay, let's keep that away. Our data access, okay, let's keep that away. So just one more thing before we end here. The evolution of software configuration management, where we are, we're on the third step. Compilation's been around for a while. Building actually came about in the last 15 years of more sophisticated steps in building and testing. And then continuous integration really came into the industry in 2005, but it's really easily accessible now. Continuous deployment is still on the bleeding edge stuff. The people doing continuous deployment, we're still figuring out what patterns work. The product landscape isn't there yet. So we're on pillar 3. And so if you're in a situation where, okay, I don't want to be on the bleeding edge because I don't want to bleed, but I do want to take advantage of all the modern things that can help me when I'm creating these new pieces of software, the third pillar is where you want to be, continuous integration, and all of the things that encompass it. And pay attention to continuous deployment products and where that's going, because very soon it's going to be accessible for people who just want to use it as opposed to invent it. Okay, so that's important. And I'll be here for the next 30 minutes before the next session. All of this code is on GitHub. I know 1 hour is not enough time to go through actually all of the code in here and the scripts and how it's put together, but it's freely available. You can comb through every detail. My email address is on the screen, and Twitter. I'd be happy to answer any questions whatsoever. And again, feel free to take all that code and rip it off totally to your heart's content, however it benefits you. So thanks for coming, and I'll stay here and answer more questions.